Hello, welcome back to Piers Rocks. This is episode number 2 in my Floppies Rock series, and in it I'm going to take a closer look at this Commodore 2031 disk drive. Now, last time around I looked at a couple of Commodore 1541 disk drives. These were designed to work with the VIC-20 and Commodore 64 lines of computers. The 2031, on the other hand, was a predecessor to the 1541 and was designed to work with the Commodore PET, which supports a different bus and a different connector type than the 1541 and VIC-20s and Commodore 64s. But I'm not going to use a Commodore PET to drive this disk drive today. I'm going to use a couple of other techniques to communicate with it. Before we do that, let's take a closer look. Okay. The first thing to say when looking at these two drives side by side, or one on top of the other, is that obviously they look incredibly similar. The 1541, being a direct descendant of this 2031 drive, uses the same case mouldings, the same half-height Alch drive mechanism, and very similar internal electronics as well. It's only when we take a look at the rear of the drive that we see any significant difference, and on the 2031 we can see the IEEE-488 connector here, in contrast to the two IEC bus connectors on the 1541 drive. The other thing that's noteworthy on this 2031 is that actually it's a 2031 LP, where LP stands for low profile. Later 2031 LPs were actually labelled 2031 LP, but this I think is a much earlier unit. So on the later units you actually see LP on the label here. Now, the final thing that I want to do before we take a look at the insides of this drive is peel off the protective film from the label on the front of this disk drive. When I picked up this unit, it was basically in mint condition. I think it's got very few hours on it at all. And I thought we could peel off this protective film together. So, are you ready? Okay, if you're familiar with the layout of an early 1541 disk drive, then this PCB, this layout should look very familiar to you. The later 1541s with the shorter board, like the two that we looked at last time, will look slightly different. The board comes up to about here, and a bunch of these 74 series logic chips have been condensed down into fewer components. In particular, the later 1541s have a dedicated motor driver IC that this PCB doesn't have. But we can see all of the familiar ICs, main ICs from a 1541 on this 2031 PCB. In particular, we've got the 6502 processor here. We've got one of the 6522 VIA chips here. We've got the other one down here, as it would be in an early 1541 disk drive. We've got the static RAM here, and then we've got the two ROM chips here. Obviously the ROMs are slightly different part numbers in the 2031 because the drive has different firmware in it. The key difference here is that we've got two additional chips that are not present in the 1541, and these take care of the IEEE-488 bus communication. So we have the 75160 and the 75161. So these are dedicated IEEE-488 bus driver ICs. Otherwise, there's not much else to say about this. To change the device number on this drive, you cut and lift either or both of these diodes here, whereas on the early 1541 I think there's a couple of traces that you can cut close by to this location. On the 1541 I looked at last time, the jumpers to cut were over in this location. Otherwise, not much else to say about this drive. It does suffer from similar faults to the 1541. In particular, it has a tendency to overheat due to the voltage regulators. In fact, when I first got this drive, I was running it for 5 or 6 hours on top of a 1570 that was also on, and this drive ended up overheating. And the symptoms of that overheating were that I was just getting constant read errors whenever I tried to do anything with this disk drive. It worked absolutely fine until it overheated, and at that point reads just failed all the time. So if I'm using this for any significant period of time at the moment, I'll do it with the lid off so that the heat can dissipate better. I'm not quite sure what I want to do to this drive in the long term, because I would like to keep it as stock and as mint as possible, seeing as it's in such lovely condition. But on the other hand, I don't want the heat from the voltage regulators to end up cooking the components, so that's something that I need to figure out. So here we have the hardware that's going to allow us to interface to the 2031 disk drive. In fact, we're going to use two different mechanisms to interface to the disk drive. We're going to interface to it via a PC, and we're also going to interface to it via a Commodore 64, and this is the equipment that we need to do that. We'll start off with the equipment needed to interface from the PC. So this is an XUM1541 device. The schematic for this is available in the OpenCBM project, and we're actually going to use the OpenCBM software to drive the disk drive with this device attached. This is a pretty straightforward device. On the one end it has an IEEE-488 connector that we'll use to hook directly to the disk drive, and the other end we have a micro USB port for plugging into the PC. We've got an Atmel processor that provides all of the smarts to drive the IEEE-488 bus, a hex inverter, and a few other bits and bobs, but a really very simple device. This is one that I laid out and had manufactured myself. You can buy these online if you're interested in getting one of these, or you can design and lay out the PCB yourself. And then the devices that we'll need to drive the disk drive with the Commodore 64 are these two. So this is an IEEE-488 Cartridge for the Commodore 64. On the one end we have the cartridge connector, and the other end we have the edge connector that most of the Commodore PET series of computer uses to expose the IEEE-488 bus. Most of the PETs do not have this Centronics 24-pin type connector, they have this edge connector. And therefore we're also going to need an adapter, because I don't have any cables that go from that directly to the sort of connector that's on the back of the disk drive. So this is just an adapter, a completely passive device that goes from the edge connector through to an IEEE-488 port. The cartridge is a more interesting device. This uses a Motorola 6821 processor to interface to the Commodore 64 on the one side and on the IEEE-488 bus on the other side. And it also has a ROM which will replace the Commodore 64 kernel when inserted and the dip switches are set appropriately. This is a reproduction of a period original IEEE-488 cartridge for the Commodore 64 that I laid out and had manufactured, and only one bodge wire on it where I failed to connect one of the traces in my layout. So that's the hardware we're going to use, and the first thing we're going to use is the XUM1541 for connecting to the disk drive using a PC. So let's do that now. Right, I've got everything set up now to control this 2031 with a Linux PC. So I'll just explain the setup that I've got here. So directly below me you can see the XUM1541 device, and then at the bottom you can see the 2031 disk drive. The lid's off so that the device stays reasonably cool and doesn't overheat. And then over there you can see my shell window to the Linux PC that the XUM1541 is connected into. I always use Linux for connecting weird and wonderful USB devices to, if possible, because I find that Linux handles USB drivers much better than Windows does. I end up on Windows with devices not being recognized or having the wrong drivers installed. But everything that I'm doing here should be perfectly feasible with a Windows machine using OpenCBM on the command line. Okay, with that said, the first thing I'm going to do is I'm going to attempt to read an existing 1541 test demo disk, just to make sure that the connectivity through to the disk drive is working and that OpenCBM can access the XUM1541 device. So the command we use to do a directory listing is cbm control dir and then the device number. So that's the correct list of files for the 1541 test demo disk. Next thing we're going to do is write a copy of the 2031 LP test demo disk, which I don't currently have a floppy disk image of. And so I've downloaded the 2031 LP D64 file from zimmers.net, and now we're going to use the D64 copy command to take that D64 and image this disk correctly. The CBM write command is used as part of OpenCBM to write individual files to an already formatted disk. I don't have a formatted disk here, and the OpenCBM format commands don't seem to work with an IEEE-488 disk drive, which is why I'm writing an entire disk image to this floppy disk. So the command we use to do this is D64 copy, and the file name of the image that we want to put on the disk followed by the device number 8. Now, as it stands, this command won't work. I think because D64 by default will assume that it's a 1541 disk drive and will attempt to use some more advanced features of the 1541 to write the disk faster than standard. So we need to set the transfer mode to original, which I think forces D64 copy just to use stock CBM DOS commands, which will work with a 2031 disk drive. So I'll kick this off now, and we should see some activity from the disk drive, which we are doing, and we are seeing that the blocks are starting to be written to the floppy disk. So I'll be back once the disk has fully written. Right, the disk image is now written. That took 7 or 8 minutes to write, so it's definitely not the fastest way of writing a disk image. I show this not to suggest that people actually use this as a day-to-day way of driving a IEEE-488 disk drive, because OpenCBM doesn't seem to have any specific support for the IEEE-488 disk drives. Just wanted to show that it does actually work, and to prove that the disk image is copied successfully, we will read back the directory listing of this disk. There we go. We can see that the information returned matches what I expect. You can see there's far fewer test programs on the 2031 LP test disk than the 1541 test disk that I previously showed. Anyway, next step is we'll now hook this 2031 disk drive up to the Commodore 64 I've got behind me with the IEEE-488 cartridge that I showed towards the beginning of this video, and we'll see if we can read this disk and if the programs actually run. So I'd better explain what we're looking at here. I've got the 2031 connected into the Commodore 64 using the IEEE-488 cartridge and edge connector to Centronics connector that I showed earlier. And I said the cartridge has a custom ROM installed on it that contains IEEE-488 support. So that's what we're looking at here. This is a ROM that's available on the internet along with the schematic for this cartridge. I've tweaked it, as you might be able to tell, changing the colours and the text slightly, but it's basically the stock ROM downloaded from the internet and installed on this cartridge. This cartridge has a number of different modes in it, so that you can use both IEEE and IEC devices simultaneously. We're not going to do that for now. We're just going to use the 2031 IEEE-488 device to begin with. And the first thing we'll do is we'll see if we can actually load a directory of this disk. Now I can't remember if this ROM has the DOS wedge on it, so I'll try that first. It does. Okay, brilliant. So we can see the contents of the disk, and we don't need to load the DOS support program here because we've already got that as part of the cartridge. So the first thing we'll do is we'll run the graphic BAM view program. Now it's worth pointing out that I think that these programs were all written for the Commodore PET, but the ones I've tried seem to work just fine on a Commodore 64. I think they're all written in BASIC. There we go. You can see that this kernel actually tells you the addresses that the program is being loaded into. So we'll run the program now, and it'll give us a graphical view of the contents of this disk. That's finished, and we can see a graphical view of the contents of the disk, where the white crosses are showing us empty blocks. The black crosses on white are showing us blocks that are used, and then the dotted pieces are blocks that don't exist because the tracks are shorter as you get closer to the center of the disk. Now we can see what we'd expect to see here is we can see a couple of tracks used, a couple of blocks, pardon me, used on track 18, which contains the directory listing, and then all of the program data is on tracks that are close to 18, so the heads don't have to move very far. The next thing we'll do is we'll take a graphical view of the 1541 test disk and see how that compares. As you can see, more of this disk is used. We'd expect that because the disk has more files on it. The next thing we'll do is we'll load the performance test and run a performance test using a blank disk. And if you can do hex maths, then you can figure out how long each of the programs I've loaded is. So I'm going to put a scratch disk in the drive now. This is my scratch disk. So this disk drive and the disk both seem to be working very well. I've now got two disk drives attached to the Commodore 64. The 2031 on top is still connected via the IEEE-488 cartridge. The bottom disk drive, the 1541, is connected via the IEC bus and is set to device 9. The cartridge I'm using can be set into different modes to access different device numbers on different buses. So right now it's set up to access device 8 on the IEEE-488 bus and device 9 on the IEC bus. So we should now be able to access the top drive as device 8 and the bottom drive as device 9. I don't have any disk installed at the moment, so this won't work, but it is correctly accessing the right disk drive. Now let's try the bottom disk drive. That's working as well. The next thing I want to do is see if these drives are write compatible. When you look online for information about the IEEE-488 disk drives, you often find a statement that the drives are read compatible, so disks written by one drive can be written by the other drive, but that they do not reliably write disks formatted by the other type of drive. So first of all, I'm going to format my scratch disk using the 2031 drive, and we'll try to write to it using the 1541. The format is completed with no errors. We'll check the disk. That's what I'd expect to see on that disk. Now, we'll put this 2031 formatted disk in the 1541 in the 2031 we're going to put the 1541 test disk. And the reason I'm using this particular test disk is because it has a copy all command program on it. I guess it must be unicopy. Let's try that. Universal disk copy, not single file disk copy. We do not need to change a unit number. We're going to copy from this device, device 8, to drive 0, to unit 9, drive 0, and we shall copy everything. So we hold down Y as every file name comes up, and it will copy all of these files over to the disk that we just formatted. And this will show if it's produced a disk that 1541 can write to. Do I want to new it? No, because I've just newed it. So that looks like it's completed successfully. We will look at the disk we just wrote. There we go, that looks correct. I'll just do that again. We can see that it is the disk that was formatted with the 2031, but then written with the 1541. We'll now try it in the other direction. Okay, we're now going to format the disk, the scratch disk that's in the 1541. Check what we just formatted. Okay, we'll now swap the disks over. So we're now going to copy the 1541 test disk that's in the 1541 to the 1541 formatted disk that's in the 2031. I guess we'll need to load unicopy again, because I loaded the directory listing. So we want to load unicopy from device 9. So this time we want to copy from device 9 to device 8. I want to copy everything. And we do not want to new the output disk. That seems to have succeeded as well. We'll just check the disk. So it looks as we'd expect it to. Try loading one of the files. I thought I'd finish this off by loading a game on the 2031 disk drive using the Commodore 64. Now, it's very difficult to find a game that will load successfully on the 2031, either because the game includes a fast loader or copy protection, or both, that's incompatible with either the kernel on the C64 or the ROM in the 2031 disk drive, or both. But I have found one game that will load, and it's a brutally hard game. Aztec Challenge. Right, I need a joystick. Ah! I hope you found this exploration of 2031 Commodore disk drive and using it without a Commodore PET interesting and informative. You can use any of the techniques that I've used in this video with other Commodore IEEE-488 disk drives without a Commodore PET. I'll put some links down in the description of projects that you might want to check out if you want to recreate what I've done here today. And if you enjoyed the video, I hope you'll consider subscribing to the channel. Next time around, I'm going to stay on the theme of 2031 disk drives. You can see I've got another much more yellowed disk drive next to me, as well as having a 40-a-day Marlboro habit. This other disk drive harbours another little secret, which I'll reveal next time. Until then, rock on.